This video is on how to make a solution of a particular molarity. Molarity is a way of describing the concentration of a solution. And just like all solutions which don't have a definite composition, it is describing a ratio. In this case, it's the ratio of moles of solute to liters of solution. Now, the best way to show how this works is to actually just do a problem. So I'm going to do one right now. Ready? So we're going to make 0.50 liters of a 4.00 molar, that's molarity, solution of NaOH. That big M, you need to recognize that. That big M is molarity, all right? So we're going to plug the numbers into our equation. We're going to use the top equation first, okay? And we're going to solve for the thing that we don't have, right? We have the volume. So we have 0.500 liters. And that goes right here on the bottom here, right? We don't know the moles of solute. And the idea is if I'm making a solution, I need to know how much stuff I want to dissolve in my water. That's really what I want to do, right? So the total volume of the solution, which includes both the water and the solute, will be 0.500 liters. We know the molarity is 4.00 molar. Now, a little side note here. The units don't look like they cancel, so I'm going to do a little side thing down here to show you. Molarity is equal to moles per liter. When we cross multiply, we're going to end up multiplying by liters, and the liters are going to cancel out, so we'll get our answer in moles. The Regents doesn't care. I don't care. As long as you know when you go molarity times liters, you get moles, I'm good, right? So we're going to cross multiply, which means we're going to taking 4.00 molar times 0.500 liters, and that gives us, 0.5 times 4 is 2, basically, right? That gives us 2 moles. So in order for us to make up this solution, we need 2 moles of our solute. Okay, if we dissolve 2 moles of our solute into 0.5 liters of solution, we will have 0.500 liters of a 4.00 molar solution, right? So you can, if you want also, you can just look at the formula as this. It's basically molarity equals N, which is moles over volume. So if you want the number of moles, just do M times V, and that gives you the number of moles that way. That's really what I just did, all right? Now, I need to know that the mass of 2 moles of solute. The good thing is the gram formula mass here is 40 grams per mole. So I can do a little side math there. Do my 2.00 mole, right? Do 1 mole is 40 grams. Now, obviously, I'm hoping the majority of you are doing this in your head and realize if it's 1 mole weighs 40 grams and 2 moles weighs 80 grams, that means we're going to have to dissolve 80 grams of solute to make a final volume of solution of 0.50 liters. Now, you may have noticed, I keep not saying we're going to add 0.500 liters of water. I keep saying to make a final volume of 0.500 liters, because that's what the formula says. Watch how we would make the solution in a step-by-step. Step 1, okay? What we do is we would pour a little bit of H2O in here. Little H2O. Right? Step 2, add 80 grams of NaOH and swirl. The idea is this. When we're doing this, we didn't fill it up to the 0.500 liter mark. Now, this is a volumetric class. It's used for making these solutions, and it's very accurate. Okay? So what I'm going to do is I'm literally going to take this and swirl it around until the 80 grams completely dissolves. At that point, I'm then going to, step 3, fill to the 500 milliliter mark. Now, the key thing that you want to notice there is I never measured the amount of water I added, because it doesn't matter. Because the solute will take up some of the space. So all I need to do is make sure the final volume of the solution is exactly 0.500 milliliters, which is 0.5 or half a liter. That doesn't mean I add, make sure we're clear, did I add 500 milliliters of water? No. I added enough water so the final volume was 500 milliliters. It will show up in questions, and it will show up on the Regents. Let's do another problem. Here we go. So you dissolve 120 grams of NaOH in water to make a solution with a volume of 2 liters. What's the molarity? Now, what you want to recognize is this problem right here, okay, is the exact opposite of the other problem. So in this problem, right, I'm starting with the amount, right, and I'm given the volume, and I want to know, this is what I'm trying to find out this thing right here, which is what I was given as a starting point before, right? So we have 120 grams of NaOH. Now, if we want to make a solution of it, and we want to know what the molarity is, we need to know the number of moles of solid. We understand that this is our solid, that we're going to dissolve, it's going, right, and we're going to figure out how many moles it is. Now, I'm hoping that at this point, everybody already knows that this is 3 moles. But if not, I'm going to divide by 40.0 grams is 1 mole, and that will give me 3 moles of NaOH. So now I know I have 3 moles of NaOH. Now, for those that remember, the formula is molarity equals N, which is moles, over liters of solution. N being equal to moles, big M being molarity. So if I want to know what the molarity of this thing is, I just have to if I have this and this, I'm good to go. And I am good to go because I have 3 moles of NaOH. So the N is 3.00 mole of NaOH. That goes on the top. And on the bottom, I have the volume in liters. It's 2.00 liters. And that equals 1.5 molarity. I should have an extra 0 from doing safe face. And that's the answer. That's the concentration or molarity of that solution. Now, how can I make these problems more difficult? Well, instead of liters, I can give you, guess what? Milliliters, right? I can give you a number that's not even, so it's not really easy to do. But there's really only 2 formulas here, right? And they're both on the back of the reference table.